All right, 10.2, finding arc measures. This is the second lesson for chapter 10. Keep in mind, there's going to be a quiz after 10.3. So let's go ahead and get started. We're going to go ahead and cover arcs of circles, finding arc measures. So looking at this first slide, it's asking for central arcs. So looking at central arcs, we know where the center is, and it's where my vertex meets at the center, okay? The angles whose vertex is the center of the circle. So when I'm looking at this, I'm calling this, again, we have to go back to our angles. This is going to be angle ABC, where my angle is, right? Let me get a different color. This is my angle. So that's angle ABC right here. And it's specifically looking at angle ABC is a central angle because it's at the center of my circle. This is called circle B. Okay, something else that we should know is that my central angle is made up of two radii. Okay, so I have a radius here and a radius down here. So something we should know. Again, you have to know how to write your angles. So if you forgot how to write angles, please go back and look at how to write angles, because you guys will have to do that. All right, looking at the next slide, arcs. How are we naming our arcs? Arc is broken part of a circle. It's a broken part of a circle, and we'll look at it in the next slide. There are three types of arcs. You have a minor arc, a semicircle, and a major arc. These are pretty easy to remember if you know what minor and major means, and then we should kind of have an idea of what semicircle is. So minor arcs are arcs that are less than half the circle. So what does that mean? That means it is less than 180 degrees. So looking at my minor arc, it is less than 180. Keep in mind I'm going by degrees still. Looking at my semi-arc, it's half the circle. So if a circle is 360, half of it is 180. So this is exactly 180 degrees. And then looking at the last one, a major arc, greater than half the circle. So this is going to be greater than 180. Arcs. So now we're going to go ahead and determine where those arcs are and what arcs are. So given that DC is the diameter, so they're showing you your diameter. Diameter means it goes straight across. This is my diameter right here. So knowing that this is my diameter, arc AC. So just go ahead and look at it before you guys start writing it in. Looking at arc AC, which is right here, this we can tell that it's less than half of my circle. So this is called my minor arc. Please pay attention to this. Your arcs are written with a curve above it. Okay, please do not put a line. You can write the word arc, but you're going to see it on your test and quiz with a curve above the two points. So that's arc AC, and it's a minor arc. Looking at the next one, we have arc DAC. Please follow along how I'm finding it. I'm not going this way to A and then C. I'm following the order. So I'm going from D to A to C. So what would that one look like? I'm again starting at D, going to A, and then finishing to C. So this is the arc that I'm looking at. If I'm looking at this arc, this is how it's written. Arc DAC, and that's my semicircle. And then looking at the last one, again, following the order it's written, I'm going from A to D to C. So I'm going from arc A, D, C. Okay, A, D to C. And looking at it, it is more than half my circle, and it's not half. So this is a major arc. So knowing the difference between minor, semi, and major. Measures of an arc. So the measure of an arc, key thing here, measure of an arc is equal to the measures of the central angle. So showing you this angle is the same as this angle if I were to continue drawing my arc. So let's just say these were to continue. And drawing my arc here, it would still be considered 50 degrees. Again, it's 50 degrees here, 50 degrees here, 50 degrees here, 50 degrees here. It's going to be the same no matter how large my angle is. So answering these questions, looking at the first one, it says arc AC. This is arc AC. Can someone tell me what is the measure of arc AC? I kind of said it. What is it? Good. It's going to be 50 degrees. Is that a major, minor, or semicircle? Minor. Good. This is a minor arc. All right, looking at the next one, the measure of arc CAD. So following it, I'm going to go from C to A and then going around to D. So looking at CAD, who could tell me what is the measure of CAD? Okay, so what's the degree? What's the measure? Good, this is going to be 180 degrees, and this is a semi-circle. Keep in mind, I know they didn't tell you your diameter, but you guys will be given your diameter. So for this question, this is my diameter, DC. So segment DC is a diameter. Okay, keep in mind it's not arc DC, it's segment DC. Or you could write CD. So just so we know. All right, looking at the next one, I'm going from A to C to D. So looking at arc ACD, what's the measure? How would I find the measure of arc ACD?
180 minus 50, you can subtract that from 360.
Okay, you could do it that way. 180 minus 50. And then what did you say? 180 minus 50?
Subtract that from 360.
And subtract it from 360. You could do that, but what's another way to do that? Okay, yeah, I could do 180 plus 50, and that's going to still give me the same 230. Is that a minor, semi, or major? Good. Okay, so yeah, you can subtract this from 180 and get this measure, and then subtract it from 360. It's up to you, or you can add these two, and then that'll give you what it's equal to instead of adding an extra step. All right, adjacent arcs. Before we move on to this one, what does the word adjacent mean? Good, so we have an understanding adjacent means next to. Arcs that have exactly 1 point in common. They have exactly 1 point in common. So keep in mind, adjacent arcs do not overlap. They do not overlap. All right, just naming some adjacent arcs. Again, they do not overlap. I have arc TQ and QR, okay? They're right next to each other. I could have arc TS. Oop. Make sure I draw that curve. This should be a curve, my mistake. Please make sure you could tell the difference between a curve and a line, because if it's a line, it's going to be marked wrong. Okay, we're dealing with arcs. So TS and arc TQ. Okay, what is not adjacent? So let me just give you an example. Arc RQ and arc TS. They're not directly next to each other. I could also say RS and TQ. Keep in mind, if I were to say RS, I could still say TR, okay, or TQR to be more specific. So just be aware of that. Just remember, adjacent means next to. You have adjacent arcs. All right, arc addition postulate. What does that remind us of? What did we deal with that we had addition postulate? We dealt with angles and we dealt with segments. So this is very similar to, I'm going to write it to like, segment and angle addition postulate. Okay, they're very similar. So looking at arc addition postulate, the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. So looking at the diagram, arc AB plus arc BC equals the entire arc in total. So again, this is something similar that we've dealt with. Shouldn't be anything new. You're getting your entire arc when you're adding two segments. Please be specific. If you write ACB, that's incorrect. Okay, you have to go with what's given. All right, congruent circles theorem. Something you need to know about congruent circles theorem. Two circles are congruent if and only if they have the same radius. They have to have the same radius. So looking at this diagram here, they're showing you with your congruency marks that these two radii are the same. Okay, they're the same, so that means those two circles are congruent. All right, congruent arcs. Two arcs are congruent arcs if and only if they have the same measure and they are arcs of the same circle or of congruent circles. So they have to be the same measure and they have to be the arcs of the same circle or congruent circle. That's congruent arcs. So looking at the next slide, we have congruent central angles theorem. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So looking at it, looking at this diagram, I have my central angles. Let's just give it an example. My central angles are both 50 degrees. So that means my arcs are also going to be 50 degrees. So I know that they're congruent. Again, if and only if the corresponding central angles are congruent, then I know my angles are congruent. Okay? So they do look like vertical angles. Vertical angles are congruent, but looking at this, your two minor arcs are congruent if your central angles are congruent. All right, similar circles theorem. All circles are similar. Please be aware this is similar, not congruent. All circles are similar. Two arcs are similar arcs if and only if they have the same measure. So that does not mean they're congruent. They're similar. All circles have the same measure on the inside, regardless of how big or small. They are all similar. They are not congruent. All right, looking at this example, there can be multiple names. Who can give me one name of a minor arc according to this diagram? Really quick before we start naming things. This is a diameter, and I'm just going to draw this one all the way across. RD is also a diameter. Okay, so looking at this, who could give me one minor arc? Yes, Gabriel? Okay, good. AR is 1. Keep in mind, you could also write it as RA. I'll just write it so you guys know you can switch them around. Keep in mind, don't forget those curves. Who could give me another minor arc, Sophia?
RC.
Good, RC. And yes, you could name it CR. Don't forget your curves or it will be wrong. Your arc symbols. Next, I have two major arcs. Who could give me one major arc? Major arc, go ahead. Say it one more time. AC, be more specific. ADC. But is that a major arc? No, that's a semicircle. So I'll go ahead and write that here. We have a semicircle ADC, but let's go ahead and find a major arc. Yeah. CRD, okay? Look at the way it's written. C is going to R is going to D. You cannot go C to D and then back C to R and then back to D. That's not how it works. You're following the order. C, R, D. So looking at it, that is a major arc. So C, R, D, and again, don't forget that arc sign. Who could give me another one? Yeah. CDR, well, that CDR, that's the same one. RAC, good. RAC. And yes, there are more. R to A to C. We'll just do one more. Who could give me one more? That's not already written. DCA. I'll go ahead and write that one. DCA. Okay, that's another one. So we have one semicircle. Who could give me one more? Who could give me one more? Yeah. CRA. Good. CRA. Arc. CRA. All right, let's go ahead and name an acute central angle. Yes. AOR. Okay, please keep in mind I'm not naming it arc. AOR, we're specifically talking about an angle. So angle, AOR. So looking at that angle AOR is right here. That's talking about this angle. And then the last one, who could give me two congruent arcs? Yeah. Say it one more time. I can't do COD because that's not an arc, that's an angle. CAR. Okay, and which one's congruent to that? Two congruent arcs. Two congruent arcs. Did I say angle? I'm sorry. Two congruent arcs. Callie? RA and CD. RA and CD. Yeah, I guess we could say they're vertical angles. Oh, RA and CD. I'm sorry. RA, and CD. All right, I could also write my semicircles. Let's just say they're not giving us, technically they're not giving us the angles. And let's say I didn't know that this one was my diameter. Let's say I didn't know. I would have CRA and ADC. Okay, so let's say we didn't know. I would write for this one. So this is more questionable if they're not giving us the measurements, and they're really not. So I'm going to use my two semicircles. And I'm going to name it arc CRA and arc CDA. Okay. Again, don't forget that arc symbol. We gotta have to get used to drawing that curve because we're so used to drawing the lines. All right, looking at example number 2, let's go ahead and it says give the measure of each angle or arc. So just giving you that information, TY right here, if I drew it straight, TY is my diameter. So let's go ahead and fill this in. We're looking at arc WX. You could tell me the measure of arc WX. How am I finding that? How would I find it? Okay, so I'm going to go ahead and I'm going to add 50 and 30. It's going to give me 80 and then I'm going to subtract it from 180. And I'm going to get this arc is 100 degrees. Looking at the next question, angle WOT, which is right here. Let me do it in blue. Right here, WOT. What's the measure of that angle? Good, this is 50 degrees because again, the arc is the same as the angle. Looking at the next one, XYT, arc. X right here to my Y and going around to T. How would I find that out? Good, I'm going to go ahead and do 180 plus 30. If I added correctly, I'm going to get 210 degrees. And then looking at the last one, angle YOT, which is right here. You could tell me what is the measure of angle YOT? Yes. Good, this is 180 degrees. It's my semicircle. Good. Any questions on this one? Okay.